All right, let's move on to net exports, or foreign trade in the simplest model with government and trade. All right, so let me just click on the next slide if it will work. So introducing foreign trade. And so we're going to make two key assumptions, and really this is just determining what our net export functions look like in our model. Like, we're just making assumptions that determine what they look like. All right, so let's take a quick screenshot since it might not be obvious for you, but these are the two assumptions. The first is that exports are autonomous with respect to Canadian GDP, which means exports don't depend on Y. That's all this is saying. Exports don't depend on Y. They're not a function of Y. Actually, how we're going to model this is that exports just equal X, where X is some constant. So it's some number, just like what investment was. And there's going to be different factors that shift this number, this constant, up or down. So that's the first assumption we're making. The next assumption we're making is about imports. And we're making this assumption that Canada's levels of imports rise as Canadian GDP rises, in the sense that imports are induced. And the idea here, or the kind of the intuition behind this, is that as Canadian GDP rises, we can afford to import more foreign goods. So that's why imports are going up with Canadian GDP. And in particular, this is the functional form assumption we're making about imports. Here, imports, or IM, are going to be equal to M times Y. And what this little m is the marginal propensity to import. So what that means is, if our national income goes up by $1, this is how much of that dollar we're going to spend on imports. So for instance, if m equals, let's say, 0.1, which is what it's going to be when we look at a function in a slide or two, let's say it equals 0.1. That means if Canadian GDP went up by $1, 10 cents of that dollar we're going to be spending to import goods. That's the idea behind this M. Okay, so let's go to the next slide. And so this is what our net export function looks like. So again, lots of screenshots behind each other, so let's get rid of that one. And let's move it up a little bit. So what's happening here is that this is net exports equals exports minus imports. And all that we've done so far is assume that this can be represented by some constant x, and this second term is induced in the sense that it can be represented by something multiplied by y. Here, m times y, where m is that marginal propensity to import. So we're just plugging in these functional form assumptions that we've made. So that's all we're doing there. So just looking at that function, we can see how it changes when y changes. So I mean, if you're calculus inclined, or I say that a lot, but if you're not scared of math, or you enjoy math, or it makes it a little bit more clear, you can take the derivative with respect to y, and that's telling you how this net export functions with respect to y, or how it changes with respect to y. But you can also just use your common sense when looking at this function. So let's minimize that. Okay, so let's just take a screenshot, maybe not have the timer there. So just looking at this function, the second term is where y comes in, and we're subtracting this second term with y. So that means as y goes up, net exports is going to go down because the second term is getting bigger. Imports are going up as y goes up. So as y rises, net exports fall. On the other hand, if y gets smaller, so if the second term is going to get smaller, if y goes down, then the second term gets smaller, which means the function as a whole gets larger. So we see this kind of inverse relationship between the two. And a lot of times it's going to be easiest to see with an example and a net export function, which is what the next slide is. So let's just give an example of what a net export function could look like with numbers so we can kind of draw it out and talk about what's happening. So this next slide's a little bit busy, but let's just break it down one by one. All right, let's click on the next slide. Okay, so three factors that are going to impact net exports that we're going to talk about are foreign trade, domestic and foreign prices, as well as the exchange rate. So when we're drawing these functions, we're holding those things constant. All right, I'm going to take a quick screen grab here. All right, so let's start at this bottom left kind of panel here. And that's giving us the functional forms that we have, or that we're given, like with a numerical example, for instance. So we're making this assumption, remember, that exports are autonomous and they're just at a constant. So notice that no matter what the level of y, so this is the level of y changing and going up in this first column, regardless of whatever the level of actual national income y, the level of exports remains constant. So that's doesn't change. It's 72 no matter what the level of y. And so if we look at the graph in this top right, we see that that just means it's a flat line, right? It's just some constant number at 72. So we have exports and imports on this y-axis. We have y, or actual national income, on the x-axis. And because it's a constant with respect to actual national income, it's going to be this flat line at 72. Then we can move on to the next column. So we're going to start talking about the second column, imports. And so basically what this means is we made this assumption that m equals 0.1. So as actual national income, or y, goes up by $1, we're spending 10 cents on imported goods. And so as we increase y in this first column, we see that 0.1 times y is going up. And so when actual national income is 0, imports are 0. When actual national income is 300, imports are 30, or 10% of that. And so we can see that graph, or that function drawn out with this green line in the top right. So that's this green line, has this nice constant slope because m is equal to 0.1 no matter what the level of y. And we see it's just going up at some certain rate, in this case 0.1. So every dollar increase in actual national income, imports are going up by 10 cents, or 0.1 of that, or 10% of that. Okay, so what the bottom right panel is doing, or graph is doing, is just taking exports minus imports. So it's just graphing out the difference between that black, flat, constant export line and this upward sloping import line. That's all it's doing. And so notice this is downward sloping like we talked about before. So now we have an idea of kind of what a net export function looks like if we make certain assumptions about what m equals and what this constant x equals. But let's start concentrating, that's not what I meant to do. Let's start concentrating on, took it twice, these three factors. So these are factors that are either going to change the level of exports, it's going to change the function that is imports, or it's going to change both of them. So let's look at kind of two different changes that could take place. So let's close these screen grabs and click on the next slide. All right, so it changes in net exports. So an increase in foreign income leads to more demand for Canadian goods. So holding Canadian income constant, if some other big country becomes wealthier, they start importing more Canadian goods. Just like if Canada becomes more wealthy, we start importing other countries' goods. So what this means is if a country other than Canada's incomes go up, so they become wealthier and wealthier, they're going to demand more Canadian goods. What that's going to do is shift this x up. So if I go back to the last slide, what would happen is if we had this change in foreign incomes, this export, right now it's this constant that equals 72. If foreign incomes went up, this constant would be greater than 72. If foreign incomes went down, this constant would be smaller than 72. So it's shifting this line, or this number that represents exports, up or down, depending on if foreign income goes up or down. The second thing that can change is Canadian prices. And again, now we're going to hold foreign prices constant. So if Canadian goods become more expensive, so Canadian prices go up, this is going to decrease how many exports we have. And that should be intuitive. If Canadian goods become relatively more expensive, other countries can't afford as many Canadian goods. So they import less Canadian goods, which means we export less of our goods. Now, at the same time as this decrease in exports, we're increasing the marginal propensity to import, in that we're rotating this IM function up. And this is because Canadian goods are becoming relatively more expensive than foreign goods than they were before this kind of price change. So Canadians are going to start to substitute towards these foreign goods and away from Canadian goods. So this M in the imports function is going to get bigger. There's going to be a larger marginal propensity to import, which is going to change our net export function. We can also, in putting those two things together, net export function is going to shift down because x is getting smaller, and it's going to get steeper because m is getting larger. So that's what's happening. So here's an example of that. And so this is an example of that would take place with either changes in the exchange rate or changes in the price levels in Canada. The same thing is going to happen in either of those two cases. So like we were just saying, so let's say Canadian prices become more, Canadian prices go up relative to foreign prices. So we see this X, this constant level of export that, let's say in that numerical example last time was 72, would go down to something else, some smaller number. Let's say like 70 or 65 or something like that. So that's what this dashed x prime line is. At the same time, because Canadian goods are becoming relatively more expensive than they were before, because Canadian prices have gone up, we're more likely to want to import these foreign goods. So this whole import function is kind of rotating up. And that's because m is getting larger. So this import function is getting steeper. Because remember, the small m is our marginal propensity to import. Putting those two things together for our net export function, this is like the net effect of our net export function in this bottom right. In that it's shifting down, so the intercept is going down, and that's because of this net export, that's because this export constant is going down. And then the slope is getting steeper. And that slope is getting steeper because the import function is getting steeper. That m is getting larger. So that's what's happening when you have a change in either relative prices or the exchange rate. Think of those as like the same kind of changes. So an increase in Canadian prices relative to foreign prices, or if the exchange rate changed in the same direction. Same effect would be happening. We'd be shifting this net export function down and making it steeper. So now let's go back to our OneNote document and kind of add net exports in and kind of try to pull all this together before we talk about equilibrium in this slightly altered model. Alright, so I'm just going to continue where we left off before, or maybe it's just easier if I start again. So we have AE equals C plus I plus G plus NX. Last time we decided consumption equals A plus B times YD. We decided investments is some constant I0. Now today we talked about government purchases, where some government purchases are some constant G0, so the government can choose to spend more or less, and that's what's going to bounce this G around. Sorry, Tully's being a little loud in the background here. Remember the other function of government with taxes, and so their tax revenue equals the tax rate times national income, actual national income. And now what we just did is add this last element, so this net exports function, which is, remember, is x minus m times y, where this x is exports, this my are imports. Make it clear we're talking about the whole thing. M is equal to marginal propensity to import. Okay, so now we have all these functional forms. So again, we can start to break down what each of these things look like, and we're going to follow the same steps to solve this model. We're going to plug them all into the AE function and then slowly solve for it. Okay, so let's start plugging them in. So AE equals A plus B times YD plus I0 plus G0 plus X minus M times Y. So remember, this is like the consumption, this is investment, this is government purchases, and this is that NX. So we're just plugging in the functional forms that we solve for up here, or that we assumed up here, I should say, is a better way to put it. So we still have to deal with this YD. So we see this YD around, and we gotta remember YD is disposable income or after-tax income. So YD is Y, national income minus taxes. That's what disposable income is. So just like before, we're just plugging in what capital T equals. It equals little t times Y, and then we just collected the terms. So, all right, so that means AE equals A plus B times 1 minus T times Y plus I0 plus G0 plus exports minus imports. So that's kind of what we've done so far in this lesson. We've kind of talked our way through what the functional forms of government purchases are, how taxes work, and the functional form of net exports, in particular like autonomous exports and induced imports that depend on the level of actual national income. So we've made these functional forms. We talked about what is going to influence the level of X and the level of M. So we talked about different things that would change those in terms of foreign prices, or sorry, foreign incomes, or Canadian prices, or exchange rates are going to kind of shift those things around. And then we're just simply plugging these functional forms into our AE function, and then eventually we're going to kind of collect terms and talk about what's happening.